This is the Palisados Foundation. Palisados was created by a group of expat Jamaican IT professionals to provide equitable access to life opportunities for STEM students. Most specifically, we do this by promoting software engineering education internships for university students on the island. Each student works on one of our open source projects under the mentorship of an IT professional. Stipends are paid upon achieving predefined goals. This program is called the Calico Challenge. The IT sector is a dynamic, growing, and critical international industry that can provide significant financial growth and opportunity for our community. Our internship programs allow local IT professionals to globally compete. We started in 2016. Almost 40 students have completed the program. We have had a variety of current and past Jamaican sponsors, including the NCB Foundation, the JPS Foundation, the Grace Kennedy Foundation, the JMMB Group, Rail Decoy, Sutherland, Backyard Restaurant, Simtai Consulting, Vertis Technologies, the Jamaica Computer Society, and more. In this video, we'll be featuring the work done by students on the Pattoo project. Pattoo is a suite of software applications that gather and present time series data. In other words, data that changes over time. This could be computer system performance, stock market prices, or foreign exchange rates. Specialized software agents collect this data and send it to the central Pattoo server for storage. We also have guides on how to create agents for your specific needs. The data on the central server can be accessed easily using either the Pattoo mobile app or via the web. Let's take a look and see what the students did in 2020.
So good day everyone, I'm Gayle and I'll be presenting on my area of focus for this year's Calico Challenge, which had been making the installation for Pattoo flawless. So on the agenda for today, I'll be giving a brief background of everything I did over the summer, inclusive of the challenges I faced, the problem I had to solve, and the solution I developed for that problem, what I learned over the period, inclusive of 2 new development processes and 4 new technologies, and some potential features that future developers can implement in future challenges. So about Pattoo. As you know, Pattoo is a project aimed for capturing time series data. So oftentimes you have to install Pattoo before using it. So I'll be going over the challenges I faced while refactoring the Pattoo installation, the problem I had to solve, which was the Pattoo installation, and the solution I developed. So some of the challenges I faced included me being initially overwhelmed by the massive code base of Pattoo, because my first time working with that much code before, as oftentimes I only worked with minor side hobby projects. So this kind of took me for a ride initially. Secondly was troubleshooting in Pattoo daemons, because at first I wasn't very familiar with the Linux command line, and troubleshooting system daemons was pretty much entirely, I needed a lot of knowledge on Linux to actually easily troubleshoot them, and that improved over the period. Thirdly, after I successfully got to troubleshoot the daemons, I noticed that each machine had different results, so I had to implement a universal solution for this so that it would work on every machine consistently. And it ties into this issue, which was my unfamiliarity with Docker, because Docker was a solution I saw that would allow me to get a consistent result on multiple machines. So into the problem. So firstly, the daemons would generally fail to start, and this was an issue that arose mainly because of users' configuration values not being ideal for the Pattoo installation, and also a lot of permission errors due to the users installing Pattoo into a formulated directory, which generally was a bad practice for Pattoo, so I had to fix this in the installation. Secondly was that pip packages would not install consistently, as since multiple pip packages have different dependencies and Pattoo had its own dependency on its own, there needed to be a centralized location for the packages needed by Pattoo. Otherwise, we'd end up in what's known as dependency hell, where different projects require different dependencies and they would cause conflicts. Thirdly, users had far too many steps in installation, which left a lot of room for things to go wrong, such as keep individuals passing um, configuration values that would not work, and generate a lot of chaos. And fourthly, there had been no universal installation for Pattoo or its components. So this was mainly an issue for developers, as the code for installation was pretty much the same, but there was no centralized location for it. So I developed universal installation that would work for all Pattoo components. And lastly, and the most pressing issue, users generally did not read the documentation for the installation, which led to most, if not all, of the above issues happening and preventing Pattoo from working on their systems. So, the solution I developed. This was mainly a universal streamline installation that incorporated all the above issues I mentioned. And this had been done using a virtual environment to maintain the pip packages and to run system daemons, and also creating a Pattoo user to control everything that related to Pattoo so that the user's own configuration would not affect Pattoo's configuration. Kind of like how Docker has its own Docker user for everything related to Docker. And that ties into the next solution I need, which is creating a Docker component container for each Pattoo component. So why would I do this? To get the consistency on every machine, and also to give us more freedom for unit testing and eventually deploying Pattoo into AWS server in the future. So now I'll show you a short demo of one of the installations. So to see the help, you just type that, and you see all the arguments for the installation. Technically, you could go without reading documentation, but I still recommend reading documentation to understand how everything works. And one command, everything installs flawlessly. It may take up to 2 minutes or so, depending on your system. And then that's pretty much it. So now I'll be covering what I learned over the last 4 months. So I learned 2 new development processes and a variety of new technologies. So the development process I learned got introduced over the Calico challenge. The first had been documentation development, which is an iterative process where as you write the code, you write documentation for the code to ensure that you understand what you're writing, and also future users that are coming to work on the project will know why you wrote something. And generally this helped me to improve my code style a lot and helped me to understand more of the inner workings of Pattoo. And next had been test-driven design, which is another iterative process, but this revolves around Travis CI, a platform for continuous integration that involves you writing unit tests for your code. And if the test fails in Travis, you have to refactor your code until the test case passes. So this helped me to improve my coding style a lot, as oftentimes there were things in Pattoo that had not been tested for. So by writing unit tests and deploying to Travis, that allowed me to be confident that the code would work on my machine and other users' machines. So this was very helpful. So the technology that I was introduced to, this included Travis CI and a few new Python modules, GraphQL, and Docker. So prior to working in the Calico challenge, I had not been introduced to Travis CI, GraphQL, or Docker. So a lot of time, about 4 months, was me learning how to use these technologies. But after learning them, it has greatly improved upon my skill set, and I really appreciate that. So now, some possible future features for future developers. This includes a Docker instance for Travis CI and machine learning for charts, and a bonus feature. So why would I need a Docker instance in Travis? So this would improve the freedom we have in unit testing, as oftentimes it's really difficult to test the system daemons due to them requiring pseudo privileges to run. So now I'll get into machine learning for charts. So since Pattoo is a statistical project in nature, Implementing machine learning for the charts could actually help to provide more accurate predictions on time series data so that users would actually know where they would have to adjust their usages for their metrics in a sense. And lastly, the bonus feature, which is deploying Pattoo into AWS server with Docker. So since a Docker container for Pattoo now exists, it's a lot easier to deploy Pattoo into an AWS server now. And the reasons for doing this would be to have a 24/7 Pattoo instance because you can't have your machine on all the time. But if all the developers need to test Pattoo and the server is down, having an AWS server could allow all the developers to test Pattoo while your machine is down. And lastly, less system overhead because realistically, most machines do not have the computing capability of the ones used by Amazon. So if you can transfer that load to an Amazon server, you have more freedom for more computationally demanding tasks on your system. So that ends my presentation, and now I open the floor for any questions. Um,
Yeah, so we have a question from Sheldon. He's asking whether we had considered any agentless methods for data collection.
oh no, I hadn't.
Yeah, so at the moment, the way it works is that agents are either resident on the Pattoo server or remotely post or poll for data. So there's some polling agents and there's some posting agents that we have. And so in that case, we rely on agents exclusively at the moment. So it'd be good to know what sort of agentless strategy you're thinking about, Sheldon.
Yeah, sure. So most modern servers have a separate management interface, same thing with networking equipment that you can query separately from the OS, completely independent of what the OS is doing. And a lot of times you can get the majority of the metrics you're pulling right now. And from a security context, many companies frown upon running third-party agents on their systems. So most of the designs I've done in terms of infrastructure health monitoring, we try to make it as agentless as possible. And there are only a handful of cases where we do custom agents.
Yeah, it will be possible for us to write agents for IPMI, like you're mentioning, and we can take that into consideration. But the purpose of Pattoo is not just for creating agents for monitoring system health, but also to write ways in which people can aggregate data from other non-system sources. So for example, as I mentioned in our introduction, possibility of polling for data, for market data, for exchange rate data, for stock market data, for data related to any other systems, and not just system servers. And as a result, we created a framework that would make it universally accessible. We have guides as to how to create agents. Some of our students in the project created their own agents to actually poll. I think I saw in one case an agent that polls the Jamaica Stock Exchange for information and posts it into our Pattoo server. So we try as much as possible for it to be universal. So we have a question from Jeff Waddington from Rail Decoy. What
Yes.
was the core purpose of introducing Docker, to create reliable testing environments or for production deployment, or both?
Okay, well, actually both, because oftentimes we get different results on different machines. So by creating a Docker instance, we got to ensure that we could have more reliable test environments and also to expand in the future for deploying onto AWS and other services. No problem.
Any other questions?
Yeah, sorry, one more. I missed your intro in the beginning, so I didn't realize this was a generic time series visualization tool. But can you guys comment on how you compress the time series data? Do you offer any type of real-time inline compression right now?
No, not at the moment. The data is just
Okay.
posted straight into MySQL database.
Okay. And have you considered a time series database instead of just a regular SQL database?
We thought of it, but the reason that an RDBMS was selected was we thought that it would be easier for students to understand, and also if it were to be deployed, more legacy type RDBMS systems would be more familiar to the installers. And so, but we could potentially think of some other options there as well.
Okay, thank you.
Thank you for listening. If you are interested in participating, donating, or sponsoring our activities, then please visit our website at palisados.org. This is the Palisados Foundation.